Welcome back to 9.1, where we're trying to show you how you name ions as we're getting prepared to be able to name chemicals and write formulas from those names. In the last podcast, we talked about how you name monatomic ions, which are simply single element ions. Cations, you simply use the element name. Anions, you change the ending to an IDE ending. We also talked about the transition metals, where you need Roman numerals to say what the charges are on those ions, because they often change. Now in this next part, we want to learn how to name what are called polyatomic ions. Now polyatomic ions, the term poly means many. Atomic refers to atom, so this is many atoms, or many atom ions. It's a group of atoms that function as one unit. And so, though you are going to get a list of these polyatomic ions to use, you don't have to have these things memorized verbatim. If you don't actually take the time to study them, using that table will be very cumbersome. Okay, you pretty much want to know these things and just use the table as a reference. So, here we go. There are a few ions that it just help to memorize right off the bat. The first one is NH4+. Is the only polyatomic cation that we're going to worry about, and that is called ammonium. Ammonium. A very common polyatomic anion is OH-, and we call that hydroxide. There's another ion, Cn-, that is the cyanide ion. Excuse me. And finally, as far as the first couple that you might want to memorize, it has the formula C2H3O2 with a 1- charge, and that is called acetate. Now those are something that I don't really have rules for you to use to name them. And again, do you have to have them memorized? Well, it helps, but you will have a list to work off from. Alright? Now in the next set, there's a few set of rules that would really help in trying to learn these polyatomic ions. What I always tell everybody is to know your eights, then your ites, your pers, and your hypos are just rules. Now what does that mean? Well, let's start with ClO 3-. Chlorine, when it is attached to oxygen, is called chlorate. So that's an 8 that you want to know. If I take nitrogen and attach it to oxygen, in this case 3 of them, with a 1- charge, we call that nitrate. Now, I could run off a bunch of extra ones. Let me just do a couple down here. If I had BrO3-, that would be bromate. And if I had IO3-, that would be called iodate. Now, as it turns out, whatever chlorine does in terms of its polyatomic ions, the bromine and the iodine will generally do the same thing. So if you could easily substitute in bromine and iodine for chlorine at any point here. Now, not all 8s, if you will, have a 1- charge. For example, you could have CO3 2-, and that is called carbonate. Not all 8s will have just 3 oxygens. Sometimes they'll have 4. So I'll have SO4 2-. Sulfur turns into sulfate. And some do not have a 2- charge. Some even have a 3- charge. So if I give you PO4 3-, that would be called phosphate. Alright, so those are your 8s. Now, once you know your 8s, and there are others, but we're just going to start with those. Once you know your 8s, one less oxygen turns the 8 into an ite. So if I take the chlorate and remove 1 oxygen, so now it's down to 2 of them, we call that chlorite with an ITE. Similarly, If you remove one oxygen from nitrate, you get nitrite. Now, I have never seen carbonite except for in a Star Wars movie, believe it or not. If you're a Star Wars fan, you've heard of the term carbonite, but they're really not talking about the same thing. You could do the same thing with bromate and iodate. If you remove one oxygen from bromate to form BrO2, 1 minus, that would be called bromite. Or if you removed one oxygen from iodate, that would be called iodite. I'll just put a little squiggle line in here to divide those out. If you take one oxygen away from sulfate, it's now down to SO3, 2 minus. That is called sulfite. Now you might be wondering right now, wait a minute, why do some 8s have 3 oxygens, some have 4? Why do some have -1, some have -2s, and even one with -3? That goes beyond the scope of this class. The reason why they're named 8s deals with their structure, and we don't want to go there yet. And for right now, you kind of have to have them memorized, but again, you will have a table to work with as you take your tests and your quizzes. All right? Getting back to our discussion here, if we have PO3, 3 minus, we would call that phosphite. There you go. Now you can remove one more oxygen in some cases to form ClO 1 minus, although oftentimes they put the oxygen in front, so we're going to put those two together just so you know. And in that case, you have the prefix hypo added. The prefix hypo simply means below. So if you suffer from hypothermia, your body temperature is dropping below what it normally should be. If something is, say, a hypodermic substance or a needle or whatever the case may be, if you're dealing with medication or a skin layer, that means that it's below the skin. Okay, hypo means below. So if you have hypochlorite, the oxygen level is below that of chlorite, and so you only have one left. Similarly, you could do the same thing with bromite and iodite. You could have BrO minus or IO minus, and this would be hypobromite and hypoiodite. All right. Now, I haven't seen hyposulfite or hypophosphite myself, but I'm sure it's possible. Now, if you drop one more chlorine oxygen from that, you are no longer a polyatomic ion. If it's just Cl minus, we would just simply call that chloride. And again, it's no longer polyatomic. We just have to use the IDE ending. Now, in some cases, we'll add oxygen back on. So if we go back up to chlorate and add one more oxygen so that it's ClO4 minus, when you add extra oxygens, you give the prefix per. So instead of being chlorate, this is called perchlorate. And similarly, if I put a squiggle in here and leave a little room here, we could have BrO4 minus, which would be perbromate, or IO4 minus, which would be periodate. Which, by the way, leads us to a couple of oddballs. I'm going to scroll back up towards the top here. Oops, excuse me. Now, don't write this in quite yet. Just kind of follow along, and then you can add in. If I have O2 minus, that ion we've already talked about is called the oxide ion. If I add an extra oxygen to it, it was a 1, now it's a 2. It is no longer oxide, but we call that peroxide. And if you stick it with hydrogen, it's hydrogen peroxide that is used as an antiseptic. Similarly, you could have manganate, but if you add an extra oxygen to it, that would be permanganate. So that's where those two odd polyatomic ions come from. All right. Scrolling down. Finally, you can add hydrogen to many of these polyatomic ions. And in fact, we're running a little bit short on time, so I'm going to just stop right here and then finish off this section in the next podcast. Stay tuned. We'll see you back in just a couple of minutes.